if you don't have the luxury of knowing the angle of the vector with the axes, this is the axis and this is the vector. Now if you don't know the angle between x-axis and the given vector, then you cannot straight away write the component of the vector along x-axis. It won't be as straightforward as we have seen now. You cannot do just r cos alpha and get the component because you don't know this angle. So you have to think about something else. Now that something else could be like, you know the angle between the xy plane and the vector somehow. Somehow you have figured out, you have calculated, you have done whatever, and you have known the angle between this vector, the given vector, and the xy plane. This is the xy plane. Okay. Now if you know that, then what you can do is you can resolve this vector into two components. One component will be lying in the xy plane and the other one will be perpendicular to xy plane, and that will automatically lie along z-axis. Now suppose this angle, the angle between the xy plane and this vector is theta. So when we resolve that vector, what we get, one component cos theta 1 would be lying in the xy plane and the sine theta 1 would be lying along z-axis. This we have learned to break the vector. So what we will get is, suppose this is the axis and the vector is lying like this. So when we break, and suppose the angle is theta between the xy plane and the vector. So when we break the vector, this r cos theta will lie in this xy plane. Suppose this is r cos theta, and r sine theta would be lying perpendicular to this line, and that will automatically come along z-axis. So what we have is this. What we have are two vectors. One is lying along xy plane and the other would be perpendicular to this. So actually we will have this kind of triangle formed, isn't it? So this is the vector r cos theta, this component, r sine theta is this component. Okay, so this, suppose you have resolved the vector and you have got rxy. Rxy is a component that is in the xy plane. Rxy is r cos theta and rz is r sine theta, which is along the z-axis. Now next what we have to do is we have to resolve this vector again. Now this is a vector in 2 dimensions, and this we have seen many times. So suppose this angle somehow again you have calculated, figured out this as phi. Then this will be very easy for you to again break this vector into x component and y component. The x component again will be this magnitude into cos phi. So the x component rx would come as this magnitude. Now this magnitude is r cos theta. So this will be r cos theta. This is the magnitude into cos phi. Cos phi. Similarly, ry will be r cos theta sine phi, and rz we have calculated already as r sine theta. So this will be the case when you know the angle between the vector and the xy plane. This is how you would do, and the same analysis would go if you know the angle between the vector and, instead of xy plane, xz plane or yz plane. The analysis will remain the same. The variables will differ, but the same thing you'll have to repeat. Now this is how you will resolve the component. This is the second way of resolving the component. This is actually pretty much the same, simple, easy. You just have to take the component in the direction in which you can, because you was given the angle between the vector and the xy plane, so you could resolve the vector in xy plane and perpendicular to that. If you have been given in some other angle, given in some other direction, you can resolve. But basically the concept is, when you have been given the angle between the vector and a line, this is the vector and the line theta, you can quickly resolve the vector along the line and in the direction perpendicular to that line. This is what basically you have to do. Fine. So these will be the basic 2 approaches of resolving a vector in 3 dimensions. You can have to do something else if some other information is provided, that you will learn as and when you solve more and more problems and go further into the course. So this completes basically the theory for addition and subtraction of vector. Now we will solve certain easy problems to open up your mind and actually broaden your understanding of this. Now before I go into helping you solve certain problems, I would like you to think about something which you might have occurred into the mind of some of you. See, I told you basically we discussed two ways of resolving a vector. Now I want to think about something. Now this is how the axis is, and suppose the vector is like this. Now in the first way of resolving, when we knew the angle between the vector and the x-axis straight away. Now what I said that we can directly resolve the vector by taking cos alpha, taking the x component, taking the component of that vector along x-axis directly by multiplying cos alpha with the magnitude of this vector. You can do that straight away. Fine, if you do that, you get certain x component. In the other method or in the other situation, what we discussed is if we don't know the angle directly, but you know the angle between the vector and the xy plane. So you take the component of this vector in the xy plane first. So when you do that, let me draw the axis once again. You have a vector like this and you take the component. Now when you take the component, of this vector, then you get something like this. Tip of this vector is vertically below the tip of this vector because they are going to form a right angle triangle. So when you take components, tip of this vector and tip of this actually lie in the same straight line. So when you have a vector like this, then the tip of this vector and tip of this vector are going to be in a same straight line. So this point is going to be vertically below the tip of the vector you are resolving. Fine. Now you got this component. Now what for the x component, what you did is you again broke this vector into x component and y component. When you do that again you have to form a right angle triangle like this, and you get x component vector like this. This is what you would do. And again the tip of this vector and this would be in a straight line just below the